So welcome to lesson 11, where we will look at unit testing and test-driven development. So if we look at the agenda, so we looked at software methodologies, then we started with looking at requirements, then we looked at analysis, then architecture, then design. The last two lectures was on implementation, and we looked at clean code and API design. So how important is it to write good software, high quality software. And then this week we will look at unit testing, or actually at test automation. So we start today with unit testing, and then tomorrow we will look at Selenium, which is a tool that allows us to test web applications. Then we look at Fitnesse. Fitnesse is a tool I go into that, but Fitnesse and the last 2 days is behavior-driven design. That are both two tools where you also include the product owner in your testing. So typically when you have a tester in your project, or you do the testing, you're the tester maybe, then you use some testing software. Now that testing software is a sort of test tool or framework or whatever it is understood by the tester, not by the product owner. So if you write your test in that tool, you cannot ask the product owner, are these tests correct? Because the product owner cannot understand the test that you have written in that tool because they're tool specific. Well, both Fitnesse and behavior-driven development is both a tool where you write basically your test so that it is readable by a human, or readable by the product owner, by the business. So we'll look into that in all the details when we get to that. So today is unit testing and test-driven development. So first, test automation. Well, today you hardly have to convince anybody that test automation is a good thing to do. And nowadays, when everybody does Agile, in Agile, for example, in Scrum, you have a sprint of 2 weeks. It is impossible to do all your manual testing in 2 weeks. And if you do that, so let's say from the 2 days a tester has to do all the manual testing, then the next 2 weeks, the next sprint, again we have to do all this manual testing, and the next sprint again. So it's not very efficient to do it manually. So here manual, you write code, you upload the code to some place, you build it, you run it, and then you check the log files, the database, whatever you need to check, and if it doesn't work, you repeat the whole process. So manual testing, typically what testers do, they have certain test scripts. First click this, then fill in this, then do this, then do this, see if this appears, then do this, see if this happens. Very long test scripts, takes a lot of time to create, and it takes a lot of time to execute these test scripts. It's not really efficient. Now, here we have a graph that says basically, what does it cost to fix a bug when you find them at a certain time? So here in the beginning, when you find a bug very fast, typically just after you programmed it, here it is $5 to fix that bug. If you find it later in time, it's $50. If you find it later in time, 500, even more later, 5,000. So what you try to do, so that this is results from research that I did at Google, but I did a lot of research as this. And it's basically the further you come in your project when you have to fix a certain bug, the more and more expensive it is. So you want to find mistakes and bugs early. That's what we want to do. And that's why we want automated testing. Now, you cannot do everything automated. So for example, test the look and feel. Test if it works nicely or intuitive. If your screens are correct, etc. That you still have to do manual. But the nice thing of automated testing is you can run it anytime. So there is an investment up front. Once you have these tests, then you can run it anytime. So there's a lot of advantages. We'll go over all the advantages. But here, if you compare manual testing with automated testing, well, manual testing is a pretty boring job. What you see, and this is not everywhere the same, but a lot of testers that have the profession tester, I'm a software tester, don't have an IT background. They studied something else, and then often even sometimes they couldn't find a job in that area, or they say, hey, in IT they have high-paid jobs, I cannot do that. But often they don't have an IT background, and they learn a trick, the trick of manual testing. So they went to courses, they learned about testing, what's important about testing, and then they became a tester. And most of these people do manual testing. And they create these scripts, and the good thing about these testers is they look at the software with a completely different angle than that developers do. Developers look at their development angle and then, oh, it works, okay, let's continue. And the developers often don't look at the border case, what can go wrong. That's the angle that testers have, what can go wrong, and let's check that and write tests for that, or do tests for that. But at least for developers, that's pretty boring job to do that all the time. So you have this test script. Once you have it, now you have to go through all the test script. Maybe a month from now, you go through the test script. Maybe a month later, you go to the same test script. It's pretty boring. While automated test, well, you have to write it. Basically, the testers nowadays, they have to learn how to program. So it's completely different for them. Some have difficulty with that. Some like it, because it's challenging, it's being creative, and it's much more creative than the manual testing that you have to do. So manual test, not reusable. Well, at least you have to execute it all the time. Automated test, you can run it as often as you want. You can run it every 2 minutes, you can run it every hour, you can run it every day, whatever you want. Well, typically with test, you need a setup and a tear down. Before we can run this test, first we have to, let's say, fill the database with this data. Otherwise, it doesn't work. And at the end, we have to clean up the database. Well, in automated test, you can automate that. Let's clean the data, let's fill this data, run the test, clean the database again. Done. All automated. Manual test, high risk to forget something. You have the script, but it's high risk that you forget 1 or 2 points in the script. With automated tests, that's not possible. Everything will run. A manual test doesn't give a safety net, while an automated test does give a safety net. Who needs that safety net? Developers. So it's if you have, and that's typically situations you get into, you're working on this project with 10 million lines of code, and you have to change some code. Then you need a safety net to see if everything is still working. So you cannot so you cannot write 3 lines of code and do all the manual testing. It's not possible. But you can write 3 lines of code and run all the tests. And if something goes wrong, it must be these 3 lines of code. And then you fix it, and then again you write a few lines of code, you test, and then see if it's still working. So at the end of the day, you can make a lot of changes and still have confidence that everything still works. Well, that only works, and that's one of the challenges of automated tests. It gives you maybe the wrong feeling that everything is tested well, that safety net is big enough, it's good enough to be a safety net. Well, with automated tests, it can be that you also forget to test something. So it's important that you test as much as possible and you put a lot of effort in automated testing. Similar as we've seen in quality of the code. You have to put a lot of effort in the quality of your code and the quality of your APIs. Same here, you have to put a lot of effort in testing and the quality of testing. Because writing tests is also writing code. You have to maintain that code. So that code should also be in the highest quality. And you want loose coupling between the test code and your implementation code. So you want loose coupling in your implementation code, you want loose coupling in your test code, and you want also loose coupling between them. So one of the challenges is, or one of the traps you really have to be careful about, because you write more tests than methods in your implementation. So for every method, you typically have a number of tests, maybe 20 tests for one method. Well, what you don't want, and that's a trick here, if I'm going to change something in my production code, and it takes me 5 minutes to change it, then I don't want that it takes me 3 days to update and fix all my tests again. That happens if you have tight coupling between your test and your code. So you need loose coupling there. So we will look at how you do that. Well, manual tests, low training value, automated test is part of your documentation. So we talked about that when we talked about documentation of a project. Your test is a large part of your documentation. So we have overview documents, the details are in our tests. That's basically we replace the old documents with tests. Manual testing, slow and time consuming, automated test, fast. And it needs to be fast if it wants to be a safety net. So what I said, typically I don't have to convince people that automated testing is a good thing to do. In general, in the field of software development, almost everybody knows automated test is the way to go. So what I told you, the last number of years, more and more people became aware, software people became aware that quality is important and test is part of quality. So here what I said in Agile Scrum, in this 2-week sprint, you don't have time to do all the tests manually. If you want to have an Agile project, you really have to go into automated test Otherwise you work very inefficiently. Now, advantages of automated tests. First, they are reusable. You write them once, you still have to maintain them, but you write it once and you can run it as often as you want. So you can run it anytime you desire it. So what typically the way developers work these days is that you check out code. So we have one code base and all the tests have been run on that code base and all the tests passed. So that code base that we have at this moment, all the tests pass, so it's correct according to the test. I, as a developer, I come in on Monday morning, I check out software because I have to implement a new user story. So I check out the classes that I need and I'm going to make changes. For these changes, I write new tests. Maybe I have to update a few old tests as unit tests. I run them locally on my machine. Everything is correct. I place that code back. So the code goes back to the code base. That code base is connected to a continuous integration server. What's a continuous integration server? It's a build server. What does it do? It compiles all the software, it builds all the software, whatever it needs to do, runs again all the unit tests on it, runs all the integration tests, and we look at unit test, integration test, runs all the acceptance tests, all automatically. And if there is a failure, as a developer, you get to know that. Either you get an email or whatever, and you have to fix that bug. So at any moment in time, or code base, all the tests should run. So these tests, you're typically dealing with it every day. You write a few lines of code, run the unit test. Few lines of code, run the unit test. There you run it maybe every so many minutes. Before you're going to check it in, you run all the tests again. When it is checked in, all the tests are running again. So these tests run all the time. You get more confidence in your code because that safety net. So in these 10 million lines of code, you change something. Didn't I break something somewhere else? The code that I didn't touch, but it might be that your new change break code somewhere else. But again, be very careful with confidence. The better your tests are, the more test coverage you have, the more tests you have, the more confidence you can have. So it makes it possible to change or refactor code. Without tests, and you have, let's say, 100,000 lines of code, small application, it's almost impossible to change that code because you don't know what you break somewhere along the way. It's good documentation, and that documentation is always up to date. That's a nice thing about testing. It is up to date because otherwise your test is not accepted. Your software is not accepted if the tests don't pass. You find bugs fast, so we've seen the earlier you find bugs, the cheaper it is to fix that bug. Well, this allows you to find bugs fast. It forces you to think about the problem twice. You have to think about it depends what you do. If you first write the code and then a test, first you think about, okay, what do I need to write? And then you think about it and you write the code. And then you think, okay, what do I need to test? So you think about that same problem again with another angle. And when you think about a test, you come up with, hey, I didn't think about it when I wrote my code. Even better is test-driven development. First think about a test, and then how should the code look like? How do I want to test it? And then think about the implementation. So both ways you think about the same problem twice. That's good. So you make sure you really understand all the details of the requirements. Collective ownership of the code. I spoke already about that. The idea is that every developer is owner of all the code for the whole project. You are allowed to change all the code. But it is dangerous if you change something that somebody else wrote and that somebody else took him or she a week to figure it out, and you just change it in an hour. So you can only change code if the tests pass. So your actual knowledge, the things you figured out before you wrote it, go in the test. They can also go in the code, but also in the test. That's your safety net. Testability and good architecture go hand in hand. Typically, when your software is easy to test, you have a good architecture, a good design. These two always go together. If something is difficult to test, then think twice. Why is it difficult to test? And typically, you can come up with a better design. Maintenance becomes much more easier because in maintenance, they get in an application with thousands of tests. So they just run the test and they know everything is working. So now I get in the maintenance department, this huge application, I change 2 lines and I run my test and I can see if everything is still working. And the test is also documentation. I can see how it is working, how it should working. And that test is also up to date. That documentation is also up to date. And you are faster. You develop faster. I come to that when we look at unit testing. So what do you do when you do unit testing as a developer? Let's say we do the test after the development, we write the code, then all kind of unit tests. Then you might think, well, it's twice the work. So that takes twice as much time. Well, they did a lot of research in this, and the end result was, of all this research that they did, developers that do unit tests program faster, even if you do twice as much work. Why? Because where do you spend most of your time? Or where do you maybe waste most of your time? A developer, if you look at how many lines of code a developer writes in a day, that's not that much. Most of the time you're thinking, researching, fixing bugs, finding bugs. So a lot of time is spent or maybe waste in debugging. Well, if you have automated tests, you don't have to debug it. Your test will tell you where it goes wrong. And maybe 2 weeks later, another bug comes up that was related to the old bug. Well, again, you have to go in the debugger. And then maybe somebody else also later in that same code has to go in the debugger. Now you have an automated test. The test will tell you this method, there it goes wrong. It's the wrong result. So automated test is just a must. So as a professional, you're a professional developer, this is part of your work. Similar as code quality is part of your work, where we looked at it, API design is part of your work. Testing is also part of your work. You cannot neglect that. And then typically in a Scrum team, design is part of your work, architecture is part of your work, analysis is part of your work, tooling and test automation and continuous integration, requirements, understanding the business is also part of your work. So maybe you didn't realize that, but the time that you have left to write code is not that much if you also have to do all the other stuff. Now, we have different types of testing. The first one is acceptance testing. So before the word testing, there's a lot of words you can put in front of it. We don't go in the Tower of Babel of all kind of words of testing, and then if somebody says this kind of testing, and then the first thing you have to ask, what do you mean with that? But at a high level, we can make a distinction between acceptance testing, integration testing, and unit testing. So what's acceptance testing? Testing the black box, testing the requirements. Does the system work according to the requirements, according what the business needs? That's acceptance testing. And most of the time, that is testing the interface. That's either a web interface, or nowadays a lot of applications are written with not a user interface, but a web service interface, mostly a REST web service interface, that with HTTP, you send an HTTP call and you get some answer back. You go to well, Amazon has all kind of web interfaces. You can through a web interface you can ask Amazon, give me all the products that start with this name, something like that. So we will look at how you do this. So typically in HTTP, a web interface you test with Selenium. Web services, there are different ways to do that, but we will look also at how you do that. Now, sometimes the tester in acceptance testing also has to do something with the database. So maybe you do something on the user interface and you're going to check the database if whatever you did here ended up in the database. Sometimes, mostly not. Or you want to check some file system, or you check if another application is called. Typically, these things are done in integration tests. So mostly acceptance testing is here at the front end of your application. Then we have unit testing. Unit testing, and there's the confusion. What's a unit? Well, that's different in every test. But the main idea of a unit test is you stay within the boundaries in Java in your JVM. In C++, it's in your memory and your memory space. In .NET is in the .NET runtime. So you stay within the boundary. The other day we talked about if you call a method within the JVM, it's 20 minutes. If you call a remote method, it's 14 years. So with unit test, you stay within the boundary of the JVM. In integration test, you go outside the boundary. Then you go to the 14 years. You go to the file system. You go to the database. You do logging. That's then typically to the file system. You call another application. You send an email. This is all integration test. So all these things that I said are typically technical things. Sending an email, go to the file system, calling another application, go to the database. It's technical code. Actually, calling another system, maybe you want to call some business logic there, but the real calling is some technical code. So there's a lot of confusion in the test world. If you ask different people what's the difference between unit and integration test, you get different answers. And the real difference is, why do we make a distinction between these two? The most important thing is a unit test is fast. An integration test is slow. That's the call to Pluto. When you send an email, when you go to the file system, when you call another application, when you go to the database, that are slow calls, thousands and thousands times slower than an in-memory call. If it is an in-memory call, it's typically a unit test. That's the main difference between a unit test and an integration test. So some people say, well, a unit test, you test one unit, and I say, what is a unit? Well, that's a class. Some people even go far and say that's a method. Well, if it's a class, that's not always true. So if I test, we looked at, for example, we looked at the example of a bank application. What is the business logic? We have an account and an account entry or a transaction, two classes that belong together. Or we have an order and an order line. Well, if I test the order, that means I have to also do something with order line. That's a unit test, even though I have two classes. Now, if, for example, the account service calls the account DEO, then it's an integration test. These are also plumbing classes. That's the main difference. Unit test, typically business logic, or at least a class that does one thing. You stay within the boundaries of your runtime, and in our case, that's the JVM. So why do we make this distinction? A unit test, a developer runs unit tests also on its own developer machine. It's fast, typically seconds. If you have a lot of code that you check out, that might be a minute and a half, but not 5, 10, 15 minutes. An integration test is typically minutes, and sometimes 30 minutes or an hour or hours. So an integration test you don't run on your development machine, because then you say start testing, and then you can go and get some coffee and then come back after 15 minutes till all the integration tests are run. So typically you do that on the test machine, because typically with an integration test you also need a setup, you need a database, you need somewhere where you can, the file system where you can write your log files, you need to be able to send an email, you need to be able to call an external system. That's the difference between a unit test and an integration test. You run them at different times on different machines. Now, we've seen this layering with the different classes and the different layers. My business logic is only unit testing, fast. This is also one of the reasons why we said a domain class is unaware of any plumbing or technical class. It's not allowed to call technical classes. And if you do that, then all the business logic, all the domain classes, is unit testing. If this account class would call the account DEO, and you want to test it as a unit test, then you have to mock the account DEO. We will look at that, how you do that, but you have to mock it. And that's not what you want. Or actually, you can avoid it if you follow this design principle. So testing also becomes easier if we follow this design principle that domain logic is always isolated. Then, or data access object, that's integration test, because you want to test if it really goes to the database. You can, well, maybe I don't want to confuse you, but you can also make a unit test of the data access object, but then you have to mock the database. If you want to test a sender that really sends something, that's an integration test, then the account service who calls these classes, It's also an integration test. And then testing the user interface, that's the acceptance test. This is how we can differentiate between these different tests. Now, the first thing we will look is unit testing. Unit testing is written by developers. Now, if you want to test a web interface, there are tools to do that. And one of them is, for example, Catalon. Catalon is a plugin in, for example, Chrome. And it records your clicks, your mouse clicks that you do, or the keyboard whenever you fill in something. So basically you say, start recording, you go to a web page, you fill in some details, you press some buttons, and then in that tool you can say, now test if this field, the value this and this is written. Now these automated tests, they have a disadvantage that it's very hard to maintain. If I change something in my application, basically it can happen that I have to change all my recorded tests. So what is much better to write the test in code. So you have much more possibilities in if-then else structures, in loops, in separation of concern, separate the test from all the coupling on a web page. We will look at how you do that.